All right, so we have this graph. Along the x-axis, we've got time in hours, and along the y-axis, we've got distance from home in miles. And it's showing Alice's distance from home as she is going for a walk. So she walks away from home and then she comes back home. So, and I'm going to ask you guys to type in the chat for a lot of these because I don't want to just be talking at you. I want to kind of lead you through this. For number one, when, so this should be a time, when is Alice's distance from home 0 miles? And there are 2 answers. Can you guys type in the chat and tell me at what times, yeah, when she's at home. At what times is Alice at home? Yeah, good. 0 hours and 7 hours. Which means she started out at home and she ended up at home. So that's good. She left and then she came back. All right, number 2, what is her maximum distance from home and when did that maximum distance happen? So how many miles away did she get and at what hour did that happen? Just by typing in the chat. What do you guys think? Yeah, good. 8 miles away. So this was a long walk. 8 miles away. Good. And it happened at time 5 hours. So 8 miles at time 5 hours. You know how you have to write maximums and minimums and how your Algebra 2 teacher and your pre-calc teacher made you write them? It was always the y value at x equals the x value. And you're probably like, why are they making us write this backwards like this? This is why. It's because when you look at a real life situation, that's how you would say it. The maximum distance was 8 miles, and then this is when it happened. So what was the total distance that she went in the 7 hours? What do you guys think? I had one person answer. Anybody agree with that? Yeah, I usually like to wait until I get more than one answer. Good, 16 miles. Because she went 8 miles away and then 8 miles back, so total of 16. All right, during what interval did she walk the fastest and what was her speed in miles per hour? Now an interval means from this time to this time. So what interval do you guys think she walked the fastest? When was she like going quickest? Yeah, good. 6 to 7 would be the quickest. Now I realize that that is a negative slope there, but the reason it's negative is because she's walking back towards home. But that's where our graph is the steepest. So 6 to 7 hours. And what was her speed in miles per hour? Oh gosh, I have you jumped on that before I could even ask. Good, 5 miles per hour. That would be the slope of this segment. It's down 5 over 1. So I realized that would be -5. Again, she's walking 5 miles an hour. It's just towards home. All right, during what interval did she walk the slowest? So when do we have the not steepest slope, the least steep? Yeah, good. That would be from 3 to 4 hours. And during that interval, it looked like she only walked like half a mile per hour. So I don't know what happened to Alice there. If she got distracted with something, but she was not walking very quickly during that time. I don't know if she twisted her ankle or I'm not sure what happened, but half a mile per hour, she really slowed down. All right, what was Alice's average rate of change between 0 and 2 hours and draw a line on the graph? So I'm gonna connect 0 and 2. And her average rate of change is going to be the slope between those 2 points. So I'm going to write down those 2 points. Starts at 0, 0, and the end of the interval is at the point 2, 5. So if we do the slope of those 2 points, and you're going to use slope formula a lot, you're going to subtract the y values and then subtract the x values. And so we would get 5/2 or 2.5 miles per hour. Now that is an average rate of change over that interval. Number 7, what is Alice's average rate of change between a half an hour and an hour and a half? Draw a line connecting those 2 points. So half an hour would be like right about here. And 1.5 would be right about here. So let me connect those. And so do you see how those slopes are different? They are not exactly parallel. Our first point is a half, and then we'll call that 2.5. And then our second point is 1.5, comma, I'm going to call that 4.75. I'm going to keep everything with like halves and quarters and 3/4 just to keep things simple. I don't know exactly what it is, but close enough. And then we're going to find the average rate of change between those 2 points. So again, that just means slope. So you subtract the y values, subtract the x values, and let's see what we would get here. 4.75 minus 2.5, what is that going to be, 2.25? Over, this will give us 1, so 2.25 miles per hour on that interval. And again, that's an average from there to there. And then number 8 says, what is Alice's average rate of change between 0.75, so 3/4 of an hour, and 1.25? And then draw a line connecting them. So again, I'm going to get those 2 points on the graph. So 0.75 would be right about here. I'm going to call that 3.5. And then 1.25 would be right about here, and I'm going to call that 4.5. And then connect those 2 points. I know you can't see that really well. It got super close together. All right, so here are those 2 points. And again, we're just going to do the slope. So it'll be 4.5 minus 3.5 over 1.25 minus 0.75. Is this bringing back memories of Algebra 1, where for like months of your life you just did slope problems? That's really all it is. It's no different from back then. All right, so this numerator is going to be 1, and the denominator is going to be 0.5. If you do 1 divided by a half, that is going to give you 2, so 2 miles per hour. And again, that's the average rate of change over this interval. And I made the interval keep getting smaller and smaller and smaller, like we're zooming in on that point, guys. What does that feel like? If we're zooming in on that point, what are we really doing here? Hint, you just took a test on it and did a whole year. Good, it's a limit. We're doing a limit around 1 hour. I'm zooming in on 1. We're getting closer and closer and closer. So number 9, bringing that all together, use these answers to the previous 3 questions to estimate Alice's instantaneous rate of change at 1 hour. Well, we had 2.5, and then 2.25, and then 2 as we were bringing it in. So it seems like we're zooming in on 2. So I'm going to say that that is roughly 2 miles per hour. And again, we can't get it exactly just from this graph, but close enough. It's just a good estimate. So then tying this all together, explain in your own words, and then ask you guys to just type in the chat just in a few words. What do you think is the difference between an average rate of change and an instantaneous rate of change? Because we just want to talk about the difference between those. And just in a few words, I'd like a few of you to just type your thoughts, like we're having a conversation, is what I'm trying to make this. An average rate of change versus an instantaneous rate of change. What's the difference? Yeah, good. Instantaneous is the slope at a point. So if this is the slope at a particular point, at a specific point, what's an average rate of change? This is slope or rate of change at a specific point. What is this then? Yeah, you guys are gonna let Abby be your spokesperson here. That's okay. This is the slope in between 2 points, or the slope over an interval. So average is slope over an interval. You're between 2 points. You get 2 points and you do the slope. There are questions on the AP exam like this. Literally, there's no calculus in it. You get 2 points, you do the slope and get your answer. It's wonderful. All right. Instantaneous rate of change is slope at a specific point. But what I want you to get out of this is that they are both slope. If you see rate of change, that means slope. And that is huge in calculus. So I just wanted to take some time and go over the difference between these.